susunod na programa ay rated G. Ito ay pwede sa lahat ng manonood.
Bawat bata may tanong,
Ba't ganito? Ba't ganon?
hayaang buksan ang isipan.
Sa science o agham, tayo na sa sineskwela. Tuklasin natin ang siyensya.
Buksan ang pag-iisip,
Tayo'y likas na scientist.
In life, nothing happens randomly or without reason. Even those events that we consider tiny are all fully dependent on the laws of nature. Ika nga nila, everything happens for a reason. So this presentation revolves around to the idea and some applications that occurs in our life that are thought to be random. However, they are based on one of the most important gas laws, which is Boyles Law. Good day, science learners! This is your science friend, Rems, and today we are going to explore the world of physics, a world where magic exists. So open your eyes, lend me your ears, and install the learning. And your mission for today is to make sure that at the end of this presentation, you can first explain what is Boyle's Law and its significance. Second is to describe the relationship between the pressure and volume and its mathematical equation. And lastly is to demonstrate different Boyle's Law application in real lives. So learners, sit tight and be ready to unveil the mystery behind Boyle's Law in thermodynamics.
In a gas, its physical behavior is described by the four variables, namely pressure, volume, temperature, and amount or mole, which refers to the Boyle's Law. But what is Boyle's Law? Boyle's Law was first formulated by the scientist Robert Boyle in 1662. In his experiment, a J-shaped tube with a shorter closed end and the long end is open. He put mercury on the tube and determined the volume of trapped gas. When he poured some mercury on the tube, he found out that the volume of trapped gas decreases while changes in the height of the mercury increases. He finally concluded that the volume of a fixed amount of gas is inversely proportional with the pressure when the temperature is kept constant. An inverse relationship is described in this way. As one variable increases, the other variable decreases. This law relates the expansion and compression of the gas at constant temperature. Having all the data, he then find out that the volume and pressure follows this graph as shown. When we write it in mathematical terms, we have this kind of formula. But how will you read the cited equation? It is read as the volume of a gas is inversely proportional to its pressure if the temperature and amount of a gas are held constant. This relation can also be expressed as P V is equals to K, or the product of the pressure in volume is equals to some constant. If we have a gas under two different conditions, we can write the general formula as P1 V1 equals to P2 V2. In the formula, we can see that under a certain condition of the gas, increasing the pressure would result to decreasing the volume, or increasing the volume would result to decreasing the pressure.
Now, let's do an experiment. One efficient way to demonstrate Boyle's Law is to use simple of two system of plastic bottle and balloon. This experiment is commonly called as balloon in a bottle or the balloon lang model experiment. To do this experiment, let us first gather the materials needed. So the materials that we're going to use are the following: 2 plastic balloon, 1 empty plastic bottle, cutter, scissors, and tape. First step, we're going to measure an inch from the bottom of the bottle, then cut the bottom off. Next step, take one of the balloons and cut off the bottom part, leaving you with only the top part may resemble a very small swim cup. Third step, using the cutted balloon, stretch the open end over the bottom of the bottle. Then put tape around the bottom to make it tight fit. Next step, take another balloon and put it inside the bottle. Then fold the bottom of the balloon around the rim of the bottle so the balloon inside hangs from the top. So here's our finished product. To test, gently pull down the balloon from the balloon membrane. This should cause the air to flow into the balloon within our model. Then release the balloon with the balloon membrane and watch as the air is expelled from the model.
Hello guys, it's me again, Rem. It is a great day to learn something new, right? Good news! I am going to perform an experiment that explains the relationship between the pressure and the volume. And this experiment is called Puff and Shrink the Magic Marshmallow. So, let's the magic begin. The materials needed in this experiment first is a 20 ml syringe and a marshmallow. For our first test, we need to open our syringe first by pulling the plunger. And after that, put one piece of marshmallow inside the syringe. And close the syringe by putting the plunger back. Remember to place our plunger in the highest point of syringe, then seal the tip of the syringe with our finger and slowly push the plunger and observe what happens. For our second test, we'll be needing the same materials and follow the same procedure. Then seal the tip of the syringe with our finger. This time, remember to place our plunger into the lowest point of syringe and slowly pull the plunger and observe what happens. As a result, when you push in the plunger, the pressure increases and the marshmallow shrink. On the other hand, under reduced pressure, the air expands to fill the syringe, causing the marshmallow to increase in size.
Hello guys, this is Crizel and today I'm gonna show you how to do the experiment in the Boyles Law Partition diver. Here are the materials that I used: empty soft drink bottle, straw, paper clip, water, and scissors. The first step is fill the bottle with water. Next step is cut the straw and bend it, then attach the paper clips at the straw. Now, test your diver. Place the Partition diver into the filled bottle of water and screw the lid on tightly. Your diver should be floating on the top. Last step is squeeze the bottle gently and watch as your diver plunges to the bottom of the bottle. As we observed in the beginning, the diver is buoyant in the water and floats on top because of the trapped air bubble, making it light. As you squeeze the bottle and apply pressure, the air bubble in the straw become more dense. Dense air doesn't float as well as air that is more spread out because it's heavier, and so the diver sinks. When you stop squeezing and remove the pressure on the air bubble, it spreads out, become less dense, and the diver shoots back to the top.
So, the only equipment that you need to use for this experiment is the large of the syringe and the small size of the balloon. Now, let's proceed now to our experimentation. The first step you do is to blow up your balloon like this. Keep in mind how large it still has fit inside your syringe. So, keep it small. Just tie it off. And you're ready to go.
The next step in your experiment is take your small balloon in your large syringe and drop the balloon inside the syringe and place the plunger at the end. For the first test, place the plunger halfway in the syringe and cover the button opening with your finger. Next, press the plunger down and watch the balloon. It shrink in size. Remove your finger from the bottom of your syringe to release the pressure. For the second test, to your experiment, we're gonna place the plugger at the lowest point. It can be without touching the balloon. Once again, place your finger over the opening of the bottom of the syringe and pull the plugger upward. Watch the balloon increase in size. To release the pressure, remove your finger to the opening of the syringe. Boyle's law states that the absolute pressure exerted by an ideal gas is inversely proportional to the volume it occupies if the temperature and mass or amount of gas remain constant within a closed system. What that means is when pressure increases, volume decreases, and as pressure decreases, volume increases. In our experiment, the balloon inside the syringe are filled in the tons of gases, air molecules. Placing your finger over the opening at the bottom of the syringe keeps the mass of air molecule constant. It creates a closed system that will allow that manipulate pressure and volume.
Boyle's law is evident in our daily living. One common example for this is when a scuba diver is entering into the water. The more he or she gains the depth, the more pressure increases with a decrease in the volume, resulting in the absorption of the nitrogen gas into diver's blood. On the contrary, when the diver begins to ascend to the top, the pressure will reduce with an increase in the volume of nitrogen gas.
Now, in order for you to further understand the main concept in our experiment, let us do some calculations.
Now, let us assume that the volume of balloon inside the bottle is 0.50 ml. If I pull up the balloon below, it exerts a pressure to the balloon of 1.00 atmosphere, considering also the air pressure of 0.33 atmosphere outside the bottle. Assuming that the temperature is constant, compute for the final volume of the balloon. Now, for our initial volume, we have V1 equals to 0.50 ml. For our initial pressure of P1 equals 1.00 atmosphere. And for our final pressure, we have P2 equals 0.33 atmosphere. So what should be our final volume? Let's compute for the numerical value of the final volume by substituting the given values to this equation. In this case, we can use the formula V2 equals V1 P1 over P2. So we have V2 equals 0.50 ml times 1.00 atmosphere over 0.33 atmosphere. As a result, the answer is V2 equals 1.5 ml.
And that's the coverage of our lesson for today, and we hope you get some information, knowledge, and understanding regarding for our presentation for this morning.